Creating, changing, and dropping constraints. Constraints. We know what constraints are already. Constraints literally constrain tables and columns in various ways. We create constraints by adding constraints when creating tables using the create table command. We change constraints and drop constraints by using the alter table command. Specifically, we can add table level constraints using alter table. We can modify table and column level constraint states only, not the actual constraints. If you wanted to change a constraint, you have to drop it and add it. You can also rename the names of column level constraints, and you can drop both table and column level constraints. This is the create table command syntax with the constraint information contained in the syntax diagram, as you can see. Constraint spec. There's a lot of it to take in at this point in time. Let's look at the alter table syntax, including all the constraint clauses. Here's the constraint state. Now let's take a look at altering constraints in a little more detail. Go back to the create table syntax. What we can do, as we've already discovered, is we can add constraints to a table either on the column level or the table level. Column level means that when you type out the column, you can attach a constraint to that particular column. A table level constraint means that when you've typed in a number of columns, you can assign a specific constraint to the table as a whole. Looking at the constraints in detail, we can assign a not null constraint to a column, unique, a check constraint with a condition which implies that something must be checked and must be correct, a primary key, and a foreign key using the references clause. Note the on-delete cascade or set null options. What this implies is that when a primary is deleted, it can delete the foreign key records by cascading downwards, or it can set values to null. You can also set the constraint state, if we look down here, to all these different values. The ones that are really important at this stage are enable and disable. Disable, obviously the constraint is not functioning. Slightly less important are validate and no validate. Validate means to validate the constraint of the existing data, or put in a better way, to validate the constraint on the existing data in the table already. No validate means do not apply the constraint to existing data, but apply it to newly inserted data only. Again, some items are out of scope. Generally, these are items that are more database administration oriented rather than SQL. The constraint alter table syntax in a little more detail. You can add a constraint at the table level. You can modify a constraint state. You can rename a constraint, and you can drop constraints. You can drop a primary key or a unique key, and you can cascade down to foreign keys. Again, here are the constraint states and the grayed out areas out of scope, database administration. We're now back with the script that creates the constant schema. As you can see, we have a not null constraint applied to the category ID column on the category table. A not null constraint is required for a primary key. As you can see, a primary key constraint named xpk category is defined on the category table on the category ID column. In fact, creating a primary key on the category ID column will probably force the column to be not nullable anyway. This word null is actually the default. It's not really necessary to put it in. It's in there for aesthetic purposes. It's not actually a constraint. A constraint is not added to this name column by placing the word null in there. Here's a foreign key constraint. What this actually is called a fishhook or a self-join. What this is doing is using the foreign key parent ID to reference the category ID on the same table. Let's look at a better example of a foreign key. Here's a good example of a foreign key. the supporting ACT table. The supporting ACT table is linked by one-to-many relationships to the ACT table and the show table. Thus, we have a foreign key to the show ID referencing the show table. We also have a foreign key to the ACT ID referencing the ACT table. What this implies is that this show ID must exist in the show table and this ACT ID must exist in the ACT table. Another constraint we have in here, which is interesting, is a unique constraint. We have a primary key constraint on the ACT ID uniquely identifying the ACT ID. This field contains a number. It's not visually identifiable. Quite often it's necessary to use the primary name on a table such as this as a unique identifying key, because you could theoretically place the same ACT in with a different ID. Since we've already looked at the create table syntax and we've gone through some examples, it is probably unnecessary at this stage to go through some detailed examples of altering constraints using the alter table command.